What?
How are you doing today?
Just spring breaks. Just been relaxing.
Can't get here quick enough, huh?
Yeah.
Now, you're in Douglas County,
Yeah.
so your spring break is this week.
Yeah.
Okay. So you're on spring break because most of my students are Jefferson County and their spring break isn't until next week.
Interesting.
Yeah. I actually like it that way because it gives me a little bit of, I'm not overloaded when everybody's in school and then nothing when people are on spring break. So it gives me a chance to break it up a little bit.
Yeah.
All right. I presume what we want to do today is pick up where we left off.
Yeah.
Okay. Let's talk about combinations and permutations because that's important to understand when you're talking about the binomial theorem. So what does n choose r equal to? That's how you pronounce this, is n choose r.
It's it's
n,
like when the
n
order doesn't
factorial.
matter.
Know that, here's the way I remember it. I know that there's that, n minus r factorial in the denominator. I also know that there has to be two n's and two r's. So there's an r factorial also. Now, what does this mean? How about if I had 4 choose 3? Well, what goes in the numerator?
I don't
4 factorial. In other words, n factorial. You with me?
Yeah.
What goes in the denominator?
3.
Well, what's n minus r factorial?
Um
In other words, let's do both terms. We got that term and we also got that term. What's n minus r?
1.
Okay, so that's 1 factorial times r factorial, which is that. Now, 1 factorial is 1, so I can erase that.
Okay.
What's that equal to? 4 factorial. First of all, what's 4 factorial mean?
It's 4 times 3 and so on, going down by 1.
And what's 3 factorial?
3 times 2 times 1.
Notice those cancel and I'm left with 4. So 4 choose 3 is 4.
Okay.
Now tell me what 4 choose 0 is.
24 or 0.
Do it this way. Don't try to shortcut it. Fill in everything you know. What goes in the numerator?
4 factorial.
Goes in the denominator.
4 factorial and 4 factorial.
Times 0 factorial.
Right.
Now, this is one of the strange things in math, is that 0 factorial is 1.
Okay.
Don't ask me to explain it. 1 factorial is also 1, but 0 factorial is 1. So what's the answer to this whole thing? What's 4 factorial divided by 4 factorial times 0 factorial?
1.
Yes. Now tell me what this is. 4 choose 4.
4 factorial over 0 factorial and 4 or times 4 factorial.
That's also 1. Notice that that is the same as that. And that's going to be critical when we do the binomial theorem expansion. Hold on a second. Close my office door so you don't have to listen to my dog barking. Now, here's the trick. So you know what those mean. So if we have an expression a plus b, where a and b can be anything, to the n power, you with me?
Yeah.
If at any point you lose me, stop me, okay? Last thing in the world I ever want to do is be talking when you're in a, you're confused. Now, well, hold on a minute. Let me cover one last thing. This means this. You with me?
Yeah.
Okay, just remember that. And if I have two quantities and I want to take it to a power, whether I want to square it, cube it, or take it to some n power, well, we have a binomial theorem that says this. And pay attention, because this is pretty complicated to understand, but there is a pattern. The third term is n choose 2, and it becomes a to the n minus 2 times b to the n plus 1. Hold on a second. Well, let's erase that and write it the following way. I'm just going to say dot, 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 because we don't know what r is. And the next term is n choose r times a to the n minus r times b to the r. And finally, the very last term is n choose n times just b to the nth. Okay? Now, that is extremely complicated looking. And no human in their right mind knows how to do this unless they just do it specifically, one term at a time. So let's figure out, as an example, what this would be. In other words, a is x, b is y, n is 3. So fill in everything. What's n choose 0 going to be? Fill it in and then we'll figure it out. What's n is 3.
Okay.
So it's 3 choose 0. A to the third. You with me?
Yeah.
Plus 3 choose 1. A to the second times b plus 3 choose 2, a to the first, b to the second, plus 3 choose 3. Excuse me, I didn't write that right. That's the last coefficient. So the a is to the 0th power and the b is to the 3rd. Now, let's substitute. First of all, what's 3 choose 0?
Just 1.
Correct. And a is x, so this becomes x cubed. What's 3 choose 1?
3.
B is y. What's 3 choose 2?
3.
And that's x, y squared. And finally, the last term is 3 choose 3.
Which is 1.
So that's how x plus y cubed would expand.
Okay.
Now, the problems they're giving you are far more complicated than this, but the nature of them is that we need to figure out the coefficients. That's all they're asking. So let's go back and look at their first problem. Expand 2x minus 4y squared to the 4th power. So let's do it in a similar way that we did the last one. Only, what are we doing? We're doing 2x minus 4y squared. So we've got 2x minus 4y squared all to the 4th power. So notice that we can use this definition. Actually, we can use this definition. What's A?
2.
A is 2x.
Right, yeah, 2x.
What's B?
Negative 4y squared.
Correct. Okay. So the first thing is n choose 0. So what's that? What's n?
4.
So 4 choose 0. And let's do it one step at a time. And the first term has the A term but no B term. Right? In other words, it's b to the 0th power. And anything to the 0th power is 1. Second term. What's this part? N 1.
4 choose 1.
Okay? And then A to the what? What's A?
It's 2x.
Put parentheses around that. What power is that to?
Do the 3rd.
Yep. Times B, which is minus 4y squared. With me?
Yeah.
Gets pretty complicated, but okay, what's the next term?
4 choose 2.
Keep going.
Oh, and then 2x.
Hold on. Yeah, hold on a second. I made a mistake. This first 2x is to the 4th power. Notice A to the nth.
Yeah.
And then what happens is the A term steps down by 1 power at a time, and the B term steps up by 1 power at a time. So this becomes 2x squared. And what's the B term?
Negative 4y squared.
And then that term is squared. You see why? In other words, look what's happening to the A term. I start out with 2x to the 4th. Next term is 2x cubed. Next term is 2x squared.
Okay.
Start with the B term. The first term is minus 4y squared to the 0th power. You don't see it because anything to the 0th power is 1. But then in the second term, the B shows up to the 1 power. Then in the third term, the B shows up to the 2 power. In the next term, the B is going to be through the 3 power And in the next term, it's going to be to the 4th power. So let's write the full thing. The next term is going to be 4 choose 3. And it's going to be 2x to the 1 times minus 4y squared to the 3. And what's the final term?
4 choose 4. Then times negative 4y squared to the 4th.
Because a goes to 0. And make sure I get rid of that fraction bar, which I didn't mean to put in there. All right, now we need to simplify this because the problem says just expand it. Okay, well, we still need to simplify it. So what's 4 choose 0?
1.
I'm going to write it. 2x to the 4th. Expand that.
16x 4th.
What's that? 4 choose 1.
1.
Remember what 4 choose 1 is. It's 4 factorial over 3 factorial times 1 factorial. So it's 4 factorial over n minus r, which is 3 factorial, times r, which is 1 factorial.
So it'd just be 4.
That's equal to 4. Okay. So that's the first coefficient. And you got to be careful about saying that's the coefficient because it really isn't. Because there's other numbers involved here. It's like saying the coefficient of the first term was 1. Well, it really wasn't. It was 16, right?
Yeah.
Okay. So what's 2x cubed?
8x cubed.
And what's, well, that's just minus 4y squared to the 1 power. Now, let's keep going. What's 4 choose 2?
6.
What's 2x squared?
4x squared.
And what's minus 4y squared squared?
16y to the 4th.
And that's a plus 16. Let's keep going. What's 4 choose 3? In other words, we're down to here.
4.
Well, it's just a 2x to the 1. What's minus 4y squared cubed?
64.
Minus 64. Because minus 4 cubed is minus 64.
And then y to the 6.
Okay. And finally, the last term, what's 4 choose 4?
1.
And what's minus 4y squared to the 4th?
256.
Y.
y8 to the 8th.
Okay. Now, still haven't really expanded it because questions that you're going to get is what are the coefficients of the third term? In other words, the very next question we're going to get asks for the coefficient of a certain term. So first of all, let's simplify this. We got 16x to the 4th plus, it becomes a minus. See why? Because I got a minus 4 right there. So what's 16 times 8? Minus 108 is the coefficient. And I got x cubed y squared. See how I get that out of that term?
Yeah.
So if they were to ask you, what's the coefficient of the second term, the answer is minus 108. And the only way we could get that number is if we actually did the entire thing. Or at least the first two terms, right?
Yeah.
Okay, let's keep going. Plus, you got a calculator in front of you?
Yeah.
What's 24 times 16?
384.
And what are the variables?
X squared and y to the fourth.
Good. It's the next term. And it's a minus. It's a minus because all of that is a minus coefficient. So what's 8 times 64? It's got to be 512.
Negative 512.
Okay, what's the rest of it?
X, and then y to the sixth.
Okay. And finally, the last term.
256 y to the eighth.
Got it. Now we're fully expanded. There's nothing more I can do. Okay? So, this answers question 4 or 5, whatever it is. But had they said, what is the coefficient of the third term? That's what it is, 384. And notice that we would not be able to come up with that unless we fully expanded it. Or at least expanded it to the first 3 terms. In other words, notice the kind of questions they're asking. Number 4 is expanded. Well, we just did. We fully expanded it. But number 5 says find the 7th term in this thing. All right. So let's find the 7th term in the next one. In other words, there aren't 7 terms in this one. There's only 5 terms. So they might have said, what's the 3rd term in this one? And the answer would have been 384. What's the 4th? Well, the answer would have been 384 x squared y to the 4th. The 4th term would have been minus 512 x y to the 6th, and so forth. So they're going to ask you about terms, and in order to answer that, you have to fully expand it by the binomial expansion.
Okay.
Okay? So, again, this time, we're doing 5x minus 2 to the 17th power. Well, let me first of all make my paper bigger. What's the first term?
Oh, the first term? 3.
No, think n choose 0.
Um,
There's always that first coefficient. So in this case, it's 17 choose 0. With me?
yeah.
A to the what? And what is A? First of all, tell me what A is and what B is.
A is 5x and B is negative 2.
So it's 5x to what power?
The 17th.
Yeah. And it's B, but it's B to the 0th power. Every number to the 0th power is 1. So I don't need to write the B part. Now, that's the first term. What's the second term?
17, choose 1. And then 5x to the 16th, and a -2 to the first.
Third term?
17, choose 2, and then 5x to the 15th, and -2 to the second.
That's 1, 2, 3. What's the seventh term? In other words, I'm not going to write the whole thing out. We don't need it all written out. All we need is the seventh term. That's all they ask about. Hold on. Find the seventh term. That's the only thing they want. So what would the seventh term be? First of all, what's the initial part? What's that part going to be?
17, choose 6.
Good. What's the 5x coefficient or exponent going to be?
12.
Seventh term.
13 to the 13th.
Think 11th. The way I figure it out is there's the first term, right? It's to the 17th power. There's the second term to the 16th power. There's the third term to the 15th power. Well, if you add the term to the power, you get 18. Well, I'm looking at the seventh term, so the power's got to be 11 on the x term, or the a term, I should say.
Very good.
And what's the rest of it? What's the -2?
-2 to the 6th.
Yes. In other words, these two numbers always add to n, 11 and 6. And notice they always add to 17 in these first three terms that I wrote there. But this power, that's the first term. So it has 17, second term 16, third term 15. That means the term and the exponent add to 18 also. So seventh term, this has to be 11. And this has to be 6.
Okay.
That's the seventh term. Now, whether that we have to do any more with that or not, I doubt it. Let me just bring up the key and see what she did with it. Find the seventh term. Notice that she doesn't even go through the first 6 terms. She knows this formula for the binomial expansion. She knows that the seventh term is 17 choose 6. Because remember, the first term is 17 choose 0. And the seventh term has an exponent of the a term of 11 and of the b term of 6. So now she can put in her calculator. First of all, she can come up with a number for 17 choose 6. You can get that out of a calculator. You can also figure out what 5 to the 11th power is. That's this number 488282125. And finally, -2 to the 6th power is +64. So now I add or multiply all my coefficients. So I got 12376 times that big long number times 64 gives us this number 3.8675 times 10 to the 13th x to the 11th. That is the entire seventh term.
Okay.
Know why? Because b was a number. B wasn't y. So that's how you do these. let's do number 6. Let me close this out. We'll do it the way she did it. In other words, when you get these that are big enough, like to the 15th power, and she wants to know what the coefficient of x to the 9th is. Wow, that's tough, right?
Yeah.
Well, here's what we have. 4x plus 3 to the 15th. Just give me the first term.
15, choose 6.
It's always 15, choose 0 to start with.
Yeah.
Okay, the next term is what?
4x to the 15th.
Times 3 to the 0th. Not going to write that. I'm going to write one more term just so you can figure out how the formula works. What's this part?
15 to the first.
15, choose 1.
Choose 1.
Times 4x to the
14th.
times 3 to the
First.
okay. So we want to know the 9th term. No, excuse me. We don't want to know the 9th term. We want to know the coefficient of the x to the 9th power. Well, that's clearly where the 4x is to the 9th, right?
Yeah.
So we're going to have that. What's the 3 going to be to?
6.
Okay, good. And what's this part going to be?
15, choose 6.
Yeah. You figured that out pretty quick. In other words, that's the same as that. Always. And this, they want to know the coefficient. So the coefficient is 15 factorial over 6 factorial times 9 factorial. That's that part. And then I'm going to multiply it by 4 to the 9th power. That's that part. And then I'm going to multiply that by 3 to the 6th power, which is that part. That whole thing is the coefficient, and I'm left with an x to the 9th. So whatever that number is my answer. Let's see what she came up with here. Hold on a second. Just a second. I think I got it. No. No, let's do it this way. Okay, so she got, if we compare her answer with mine, the first part is 15, choose 6. Well, that's this. That's what 15, choose 6 is. Times 4 to the 9th times 3 to the 6th. So she figures it all out and gets this number here. Okay.
Okay.
I don't think it's worth our time for you to go ahead and come up with these answers. I'm going to do it like we did yesterday. In other words, once we get it set up so that you can figure out the number, we're going to stop. we don't need to spend 10 minutes having you put this into a calculator to come up with this number. As long as you know how to do it. Now, do you know how to do combinations on your calculator?
Yeah.
You do?
Yeah.
So you can do 15, choose 6 to come up with 5,005, I guess is what that number is?
Yeah.
Okay. And then 4 to the 9th is clearly this number, 262,144, and 3 to the 6th is 729. And she multiplies all three numbers together to get this gigantic number down here. And that's the coefficient. Notice that she did not write x to the 9th next to that. The only thing she asked for was the coefficient. And this is the coefficient of the term that has x to the 9th in it. All right, that is binomial expansion in a nutshell. That's how you do all binomial expansion problems. And the true secret is to find this pattern. The pattern being that's n, second term that's n minus 1 and 1, third term is n minus 2 and 2. In other words, these two numbers always add up to n. That helps, because that means when you get to the x to the 9th term, it's got to be 3 to the 6th. And it's got to be 15 choose 6, not 15 choose 7. In other words, this is the 7th term of our sequence. But it still is x to the 9th power. So, and that means that this is 15 choose 6 if it's the 7th term in our sequence. So this is a little tricky. Sometimes it really is helpful when you're solving these to write out the first couple terms, sometimes even the first 3 terms, because then you see the pattern. In other words, I know the next term is 15 choose 2 times 4x to the 13th times 3 squared. So as long as I go with that pattern, then go all the way down until you get the x term to the 9th power, and you got your coefficient pretty much.
Okay.
Okay? All right.
Yeah.
That's hard stuff. But it's really not hard stuff if you're looking at the binomial theorem in front of you and you can just plug it in, which we can do. Now, let's look at number 7. What kind of series is number 7? Starting with the top brick, working your way down. Is that arithmetic or geometric?
Arithmetic.
Okay, so that I hope you don't mind if I keep using my terminology.
No, you're fine.
The only reason I want to do it is because it's what almost everybody uses. You are the first student in 8 years that uses this terminology. Seriously.
Yeah.
So if you run into it again, I want you to recognize what a sub n means. That's the same as your t of n.
Okay.
Now, we had a problem last time where she wrote s of n, and it confused me because usually when I see an s, it means sum. Everybody uses s to mean sum. So when I see an s, I see it like that. And that's not what she meant at all. She meant A sub n when she wrote S sub n. So it can be a little confusing if you're switching terminology. As long as you understand that A sub n is the same as T of n. Well,
Yeah.
how do I know? What's the general formula for A sub n?
First term plus
A sub 1.
the common difference, and then n minus 1.
Okay, so in our brick problem here, what's A sub n? Or what's A sub 1 rather?
1.
It's common difference?
1.
That's how they got that formula. The first one that she writes. So what is A sub 22? In other words, the 22nd row, if the bricklayer continues to build bricks all the way up to 22 layers, how many bricks are going to be in the 22nd layer? Well, use this formula to figure it out. 1 plus 1 times 22 minus 1. That's how many bricks are going to be in the 22nd layer. And
Okay.
the next question she wants is S of 22, which for me I would write like this. And for an arithmetic sum, it's n divided by 2, which is 22 divided by 2. The first term plus the last term. Well, that's 11. First term is 1. The last term we just figured out was 22. So it's 11 times 23, which equals 253. Total number of bricks used if you were to build 22 rows of bricks.
Sounds good.
Okay. Let's see if we can get through 8. Because 8's the last one that deals with arithmetic or geometric sequences. 9 all of a sudden goes into exponential functions, compounding yearly, compounding more than yearly, and compounding continuously. There's 3 different ways you have to learn it. And those kind of problems don't start till 9. Okay? So let's finish 8. Okay? Let's first of all read. Each section has 44 rows with 22 seats in the first row, 23 in the second, 24 in the third, and so forth and so on. How many seats are there in row 44? Give me the general equation for A sub n. Generally.
The first term plus the common difference, and then n minus 1.
Okay. So they want A sub 44. What's A sub 1?
22.
What's the common difference?
Plus 1.
And n minus 1 is 43. That's how they get 65. So there's 65 seats in the 44th row. Just using the A sub n generic or general formula and then the specific formula for this particular model. Now, each section has 44 rows. So we have to figure out all of them. So we want S sub 44, well, it's equal to the number of rows, which is 44, divided by 2, in other words, n over 2, times the first row seats plus the last row, which we just figured out was 65. So that's equal to 1914.
Okay.
And in the entire stadium, if every section has 1,914 seats and there's 25 sections, you're going to multiply that by 25 to get this answer.
So, okay.
All right, let me close out the key. We'll pick up with number 9. Hold on, I might have screwed up. Let's talk about the 3 formulas for compounding. If you're compounding yearly, your final amount is equal to your initial amount times 1 plus your annual rate of return to the number of years.
Okay.
I'm going to write all 3 of them because they're each different. If you're compounding greater than annual, meaning more frequently, then your amount is equal to your starting amount times 1 plus R. Do you use N or K in your school?
N usually.
So that's what it is. In other words, if you were compounding monthly, N would be 12. N is the number of times per year you're compounding. If you're compounding daily, N is 365.
Okay.
Finally, there's continuous, which really is the way the world works. And that's equal to your original principal times e to the RT. And the reason I write it like this is because it's easy for me to memorize that A is equal to PERT. PERT. So I use P instead of A sub 1. But it's the same thing.
Okay.
Okay? So those are the 3 formulas we're going to use depending on the problem that they give us. Well, so let's look at this problem. We've won the lottery, and we're going to choose to receive 1.3 million with 4% more each year after. How much will you have after 20 years? Well, which formula do I use?
The annual
1,
one.
2, or 3?
Number 1.
Yes, because it's being compounded each year by 4%. So give me the particulars. What's A going to be equal to?
To 1.3 million times 1.04 to the nth.
To the 20th, because T is 20.
Yeah.
And incidentally, the units that go with T is not always in years. T can be in months, T can be in days. T goes with whatever R is in. In this case, it's 4% each year. Therefore, T is in years. If it was 4% per month, then T would be in months. And we would have to convert 20 years to 240 months. So just make sure that T has the same units on it that R has. Now, you can get that number out of a calculator, right? Easy enough.
Yeah.
The way I do it is take 1.04 to the 20th power, take whatever number I come up with, multiply it by 1.3 million. What do you get?
2,848,460.
See if that's what she's got. Having, for some reason, a problem with maybe I have to open up a second window to do this. Let me try it. I appear to have closed out my Gmail, and that's where the key is. And also, you gotta find your mom's email. She sent me originally. And it's this, and it's the key. Is this problem number 8? No,
No.
this is problem number 9. I wonder why she subtracts 1. Comes up with a different answer.
That's because she found the sum and not how much she earned on that, or instead of
yeah, I'm sorry, I misinterpreted the problem. I was thinking, what does 1.3 million turn into after 20 years?
that's fine.
That's what I would have had. But she's finding the total amount of money you get. Okay, so this is still an arithmetic sum problem. And the way we're going to figure it out is the first term is 1.3 mil. Second term is 1.04 times 1.3 mil. With me?
Yeah.
So the sum of this, let's see, is this an arithmetic sequence? Yeah, we're adding 0.04 each time. 0.04 times 1.3 mil. So the sum of the first 20 terms is number of terms divided by 2 times the first term plus the last term, and the last term is what I figured out the first time through this. You remember what your answer was? 2.8, what was it?
2,848,000.
All right, we'll leave it like that. So does this come anywhere close to her number? Let's see, we got 4.1 mil times 10. So we should have about 40 million. She gets 38 million.
Because you did a arithmetic even out a geometric sequence.
Well, you're right. The second term is multiplied by 1.04, huh?
Yeah.
So each term is multiplied, not... Okay. Very good pickup. So my S sub 20 is equal to A sub 1 times 1 minus r to the nth all over 1 minus r. So that's where she got her 1.3 mil, the first term, times 1 minus 0.04 to the nth over 1 minus 0.04. And that number is the one she came up with, about 38 mil. And she did do, I believe, 1 minus r, did she not?
Yeah, or r minus 1.
She did r minus 1. Instead of 1 minus r. Comes up with the same number. Ah. Huh. All right, let's move on. The major thing was there that was a geometric sequence that I mistakenly thought was an arithmetic sequence. Okay. Let's look at number 10. Boy, these are tough. These are not easy. Hold on, let's look at number 10 without having the answers, just to see if we can figure it out. Having the answers is useful, but not when you're trying to figure it out.
Yeah.
So all it does is it just turns it into a rote problem where you just are following her example and you're not really thinking about it. So I really hate having the key there when we're trying to solve it.
Yeah.
Listen, I just noticed the time and I do have a 5:30. So let's stop with 9 and we'll pick up on 10 next time.
Sounds good.
Okay. Nicholas, you got my email that showed you how to see the link
Yeah.
of your first recording? Okay. And this recording will be on that same site, only this one will say NH032117.
Okay.
In other words, it'll have your initials with today's date.
Sounds good.
And don't ask me what I'm going to do if I get two students on the same day that have the same two initials. I thought I had that for the first time. Never has happened in 8 years. Shows you how hard it is for it to happen.
Yeah.
Because there's 26 letters, so it's basically 26 times 26. The odds of it happening are about 1 in 550. So it's not easy for it to happen. And if it does, I'll just probably put an A in front of the person who went first and a B on the file name of the person who went second.
Sounds good.
Just because you got to have different file names.
Yeah.
All right, Nicholas, have a good day, and I'll talk to you in our next session, which
is Friday.
Friday. Talk to you then.
Okay, see ya. Thank you.